Okay, so for this problem, it is how many source integers. We just check how many. So there's a counting problem. How many 4-digit positive integers? So requirement have 4 different digits where the leading digit is not 0. And the integer is a multiple of 5. Okay, and 5 is the largest digit. Okay, so this means like, okay, we have this is 4 positions, 4-digit positive integer. We just consider 4 positions, and so last one, this is a multiple 5. So multiple 5, so last one could be 5 or 0, right? Okay. So last one could be 5 or 0. So we have 2 ways. So the leading one, this one cannot be 0. So can be, let's say, so can be 1, 2, 3, 4, 5. But if okay, so here we have a question. So can we put 5 in the first position? So it depends on whether the last one we already have 5. So here we need to consider 2 different cases. Let's suppose that we just check last one is 5. Oh, last one is 0. We just check these 2 cases. Okay, so for this case, so first one we can just pick 1, 2, 3, 4, right? Only 4 ways. So here we have 1 way, and here we have 4 ways, because 5 is the largest digit. So only we can use 0, 1. So only we can use like 0, 1, 2, 3, 4, 5, right? Okay, so now we have these 6 numbers: 0, 1, 2, 3, 4, 5. We have 6, but we cannot pick 5 and cannot pick the first one. So we also can only have 4 of them, right? Yeah. Okay, so then this one should be 3, right? Yeah. So cannot be like we have 6 of them. So but cannot be this, cannot be this, cannot be this. So 3. So in this case we have 4 times 4 times 3. So many ways. So this equal n1 equal 48, right? Yeah, 48. Okay, then last one. So this is 0. So okay, the 1. Okay, so first one can pick 1, 2, 3, 4, 5. So we have 5 ways, right? 1, 2, 3, 4, 5. So we cannot pick 1, or cannot pick 0, but can pick any of others. Yeah. Okay, so there's 5 ways here. Then here, so this one, we cannot pick 0. So this one, we just cannot. We can pick 4 of them. We just cannot pick one. We cannot repeat. So if first one is 1, second one cannot be 1. First one is 5, second one cannot be 5. Just like that. So there's 4. So here same story, 3, right? Okay. So this equal 60, right? Okay. So totally should be 48 plus 60. Should be 108. So for this problem, it says every day at school, Joe climbs a flight of 6 stairs. So we have 6 stairs. So Joe can take stairs 1, 2, 3, or 3 at one time. So for example, can be like could climb 3. So here we say we have here 1, 2, 3, 4, 5, 6. We have this. So could it be just jump 3, then 2, then 1? Okay, so the question is how many ways? So for such a problem, we just check like let's say how many jumps like so we just check this number of jumps. Oh, so could it be twice? Oh, okay, if jump, so at the most each he could climb 3. So at least they need 3, need 2, right? So we say if there's a number is 2, then this means 3, 3. 3 plus 3 is equal 6, 3, 3. Yeah. Okay, so if we need 3 jumps, so 3 jumps can be like let's say like 3, 1, 2. Could it be that, right? Okay, so 3, 1, 2. Also, there's a first one, 3, second one, 1, third one, 2. Or could it be like permutate? Like could it be first one, 1, second one, 2, and the third one is 3. So from here, so we see from here we get 1 way. From here, actually we can have 3 factorial way, 6 way, right? And also can be like a 2, 2, 2. 2, 2, 2. So this is just 1 way. Okay. Okay. So if 3 jumps, we can only there's 2 cases. So how about 4 jumps? 4 jumps. So could it be like 1, 1, 1, 3? Yeah. Oh, 1, 1, 2, 2, right? So 1, 1, 1, 1, 1, 1, 1, 3. Also could be 1, 1, 3, 1, right? 1, 3, 1, 1. So here, so how many ways? So we can say we have 4 positions. We put 3 positions as 1, or 1 position as 3. Or we just from here we just pick 1 position to put 3. So we have 4 ways, right? And then other one put 1. So here, how many ways? So just let's say we have 4 positions. We put 2 1s and 2 2s. So such a problem just like we from 4 positions, we just pick 2 positions. Pick 2 positions. For those 2 positions, I put 1s. And the remaining positions, I put 2s, right? So this actually we have 6 ways, right? Okay, 1, 1. Okay. So how about 5 jumps? Need 5 jumps. So could it be 1, 1, 1, 1, 1, 1, 1, 1, 2, right? Only this, yeah. Only. Okay. So here the same way we have 5 ways. We can put put 5. No, put 2 in the 5 positions. So could it be like 2, 1, 1, 1, 1, or 1, 2, 1, 1, 1, right? So we have 5 ways. And 6 jumps. 6 jumps only 1 way. 1, 1, 1, 1, 1, 1. So okay, only 1 way, right? Yeah. So totally So we just add them up. Okay. So such a problem a little bit tough, right? Because we have many cases. So sometimes we will miss some case. So this is trouble. So we just check like we just focus on which things. So to like here we just focus on number jumps. So check it. Number jumps 2 or 3 or 4 or 5, 6. So we just have only those cases, right? So we will not miss any case. Yeah. Okay. So for this problem, it is easy. Like I think the two spinners spun once and each land. Okay. So this is the 135, 135. So each one has we get 1, get 3. The probably the same. So then, what is the probability that the sum of numbers is prime? So we just check all cases. How many all cases could it be? If this 1, could it be 1, 2, so 1, 4, 1, 6, right? Or 3, 2, 3, 4, 3, 6, and it could be 5, so 5, 2, 5, 5, 4, 5, 6. So totally how many cases? So we just we just count each one of one. We have all possible outcomes. We have 9 of them. So among them, so how many satisfies the condition? The sum is prime. So we just check it here. Okay, this one okay, this okay, this okay, right? This okay, this okay. 7. This is not okay. This is okay, not okay, okay, right? So how many ways? 7, right? So this problem, it says we have 3 digits integers containing 1 of each of the digits 1, 3, 5. So 1 from this 1, 3, 5. So how many those integer can make? So could it be 1, 3, 5, or could it be 1, 5, 3 like that, right? So totally we say just have 3 factorial. Okay. So among the 3 factorial, what is the probability that integer is divisible by 5? So if divisible by 5, then last one should be 5, right? So here only, so how many ways, how many those numbers? We have only 2, right? So 2 over here, 3 factorial is just 6 or 3 times 2, just 1 over 3. Okay, so for this problem, this is how many 3-digit positive integers have digits whose product equal 24. So let's check one of them. Let's say like 2, to 6. I think 2 to 6 is one of them, right? Yeah, 2 times 6 is the this 3 digits as a product equal 24, right? Let's check some others. Could it be 1, 3, 8? This 1, 3, 8 is also the, also those numbers, those digits, those integers. So here we want to find how many. Okay, so here let's say we just factor 24, so 24 into, let's say 24 is equal to 3 times 3, right? 3, 1, yeah. Okay, so we can write this as like a 2 times 2 times 2 times 3, or we also can put 1, or we can put 1, 1, or even we can put 2, yeah. 2, 1 is okay, 3, 1 is okay, yeah. So we say 24, we can split 24 like that. So we don't need, so maybe we don't need a 1 times 1, yeah, we don't need a 2 1 with the 1, okay. So we just, it seems like we just split this 5 numbers into 3 parts. Like if we cut this like this one, so we got this number 2, 4, 3, right? So how many those numbers? Oh, not this way. 2, 4, 3. So we cannot count for 1. We also can be like 3, 2, 4, right? Okay. So this problem, let's say we just check all like if we use this 3 number like 2, 4, 3. So for this 2, 4, 3, the product is 24. But from this 3 digits, we can make 3 factorial numbers, right? So let's say, so we here, so maybe we just list all those possible ways. Let's say, like suppose the first one is 1, saying 1, only 1, 2 or 2, not okay, 3, yeah, 1, 3, 8. So we just check it. Let's check this way. First one is from smallest to the largest. Yeah. So from, okay, so this one, so we can have 6 of 3 factorial. So 1, 3, 4, 8, and 1. How about 6, 4, or 1, 4, 6, right? Yeah. And so if we first one 1, so we have only the 2 cases. Saying 2, 2, 2, 2, 6, 2, 3, 4, 2, 3, 4. Okay. Saying how about the first one 3, 3, 3, 2, 2, no, 3, 2, 4, but the 3, 2, 4 is already included. So this is just, we have only these 4 cases. So each one, so from here, so this is, we have 3 factorial, because there are 3 numbers, 3 digits not the same. So here 3 factorial. But for this 2 to 6, we cannot use 3 factorial. We say just have 3 ways. We just put the 3 position we just pick one position as 6, then other position, other two positions 2, 2, right? So here is 3 factorial. Yeah. So totally we should have 6, 6, 6, 6, 6, 6 plus 3. Okay. Okay. So such a problem is also a little bit tough because we need to list all the possible cases. Okay. So for this problem, how many whole numbers or integers between 1 to 1000 do not contain the digit 1? So like let's say like okay like 819, or we cannot count this, right? Or 71, or we cannot count this. So how many such numbers? So maybe we can count this way, like we just say okay, one digit, or we just check this number of digits. If we have 1, then how many? Let's see. So just cannot be 0, right? Can be only 2, 3, 4, 5. So from 2 to 9. So we have 8. Right? Okay. So if number digit 2, so let's see. Okay. So first position can be cannot be 0, but it cannot be 1, right? So first position we have 8 ways, right? Cannot be 0, cannot be 1. So second position just cannot be 1, right? Can be 0. So from 0 to 9, but except 1. So we have 9 ways, right? So in 2, so we say equal 8 times 9. And if we have 3 digits, so same way, the first one cannot be 0, cannot be 1. So 8. Second one just cannot be 1. All others are okay. So 31 is also 9, right? Just 1 is not okay. All others okay. 0, 2, 3, all are okay. So if we have 3 digits, then this equal 8 times 9 times 9. So totally how many ways? So just add them up, right? So equal 8 plus 8 times 9 plus 8 times 9 squared. Okay, so this one, so we just check, okay, this equal 1 times 9 times 9 squared. So this, so we can just this equal 10 and 81, 91, right? So 8 times 91, yeah. But anyway, so we can find this. Okay, this problem says 2 cards are dealt from a deck of 4-letter card labeled ABCD and 4 green card labeled ABCD. So we have 4-letter card ABCD, 4 green card ABCD. A winning pair. What is a winning pair? A winning pair is 2 of the same color. Or so here, we have 2 cases, right? This case or this case, 2 of the same letter. So what is the probability of draw a winning pair? Okay, so let's say 2 cards are dealt from this deck. This deck is we have a 4-letter card, we have A, B, C, D, and we have those A, B, C, D green. Okay, A, B, C, D. Okay, so from here pick 2. Okay. Okay. So let's say total ways is we just we say from A to pick 2. We don't care, right? Just from them pick 2. Okay. So what is the probability that we can get a winning? So winning means a winning pair is 2 of the same color. So could it be like from here pick 2, so color same. So this is winning. Or from here pick 2, right? So this pick 2 from this 4 pick 2. Or from this 4 pick 2. So this is from same color, right? Or same letter. So let's say same letter. So how many ways for same letter? So if you pick A, so could it be like a pair of A's, like a pair of A or a pair of B, a pair of C or a pair of D, right? So this we have how many ways? We just say we have 4 ways. So same color, same color, all this we pick a pair of red, a pair of green, or a pair of same red. So this is the probability. So maybe we let's calculate this number. Okay, so let's say this equal from A choose A times 7 over 2 times 7. So this is 4 times 7. Yeah. So here the 28. Okay, saying this is 4 from 4 to the 2 6. 6 plus 4, so equals 16 over 28. Okay, still can cancel. Yeah, 4 over 7, right? Okay. We cannot finish. So we just let's stop here. Yeah. Okay.